So, hello everyone. Thank you so much for joining us. Today we have the final presentation meeting for the Omdena challenge associated with the Bhutan DHI team. So, our challenge is primarily focused on building a translator which translates the Dzongkha language to English. So, this is like the first ever NLP translator that is built across, and it will help the tourists who go to Bhutan and serve the purposes of translation and also tourism purposes. I will let our team take over. We, as a team of 40 to 50 collaborators, worked on this along with the product manager and the core Omdena team, which includes myself and Akash. So as a whole, we would like to thank the collaborators, the Bhutan team, and then we would like to begin the presentation. I'll pass it over to Akash to begin, and then we'll see how it goes.
Thanks, Arni. Good morning, good evening, good afternoon, everyone. From wherever you're joining, I'll just share my screen and I'll start the presentation. Let me know once you're able to see.
It's visible, Akash.
Yeah. Thanks for confirming, Divya. Yeah. So a background before we start the presentation or delve into what's been done and how the solution shaped. So this was basically started with an ideathon, which was conducted a few months back. It was an AI for social good in order to solve problems in Bhutan. So we have proposed a solution with respect to helping the culture in Bhutan, and it started with the one line idea in order to preserve the tradition or say the culture in Bhutan, and what can we do in order to solve that. So we have come up with a solution wherein we can translate the documents or the data which is present in Bhutan national language to English. So that was mainly the problem that we were trying to solve. And before I start, say the problem statement and the solution that we have come up with, I want to thank all the collaborators who have put in their efforts for nearly 8 weeks, though it started and it got selected through the ideathon and it got converted into an 8-week challenge. All the collaborators here, we have worked like more than 8 weeks in order to come up with a solution through facing many of the challenges through the project and overcoming them. And also the DHI team with whom I had like a frequent interaction in order to get some support from them. So the DHI team too here. So thank you to them, and also some special mentions with whom we connected in order to understand the language and also the kind of work that they have done, Mr. Karma and Mr. Yeshi. So thank you to all the collaborators. Some of them are already here. So thank you to all of them. So to give an overview, I will be starting the problem statement and the solution that we have proposed. Then my team here would be taking you through the roadmap, the demo, and even the tasks, how we have divided it into different tasks and what kind of problems that we have solved in each task. And there is a small demo of the solution that we have built, and finally the challenges and the future scope of this project. So to define the problem from where it was started, as I said before, it was just a one-line idea wherein the lot of literature, I would say, in Bhutan is basically present in the Bhutanese national language, which is Dzongkha. And though there were many other languages that are spoken in Bhutan, Dzongkha has a native literary tradition. But the thing is that Dzongkha has been underrepresented globally due to lack of appropriate translation tools. And there is a lot of written works and literature that is present in Dzongkha, making it most of it inaccessible to public without the help of interpreters. So this was the starting point wherein we thought of, in order to come up with a solution to solve this problem, wherein the youth, or say the generation of right now, the generation in Bhutan, they weren't comfortable with the national language than they are comfortable with English. So in order to understand the culture of Bhutan, maybe understanding the literature or even the important text documents and the manuscripts that are present in various government monasteries or temples. So in order to understand them, I think a translation tool or a translation would be required so that it would be accessible to everyone, not only the people in Bhutan, but everyone throughout the world to understand its culture when it is translated into a common language or widely spoken language. So that was the starting point of this project. And the solution that we have come up with is to develop a machine translation model wherein when an input data is given in Dzongkha, it converts it into English. So for that, we developed a machine translation model and also created a simple UI, which is similar to Google Translate, wherein we give an input, click on a button, a translate button, and it gets translated into an English. I understand that there are a lot of roadblocks and all that, but this there is a lot of room for improvement in order to improve this model too, so that this could be more accurate. So from this point, I'll be handing it over to my team here, who would be taking up the roadmap, the different tasks that we have divided into, and they will delve more into the details of the tasks, and they will show you the solution that we have built. So over to Divya.
Thank you, Akash. So this slide represents the roadmap that we took for this particular project. First of all, we started with defining the problem statement. Then we brainstormed upon a few possible solutions. In the process, we also eliminated some of the things that would not work for us in this particular project. Thereafter, we collected the relevant data and researched upon different machine translation models to see which one is working best for the data that we have on hand. And finally, we deployed it into a single web application. Next slide, please, Akash. So on a high level, we divided the entire project into 4 different tasks. We started with the data collection task, where we gathered a parallel corpus for training and testing purposes. It comprised of 2 different columns. One represented the Dzongkha text, and the other one comprised of its corresponding English translation. Thereafter, we improved the data by removing some unrecognizable characters. This particular effort fell under task 2, which was data pre-processing. Then came the word segmentation task. So task 3 was subdivided into 2 different tasks, which was word segmentation and machine translation. Due to the interdependency between these 2 particular tasks, we decided that this was a good effort. The input from the output from the word segmentation task was directly used by the machine translation task. And finally, we deployed the model on an Azure platform so that we can provide a scalable, user-friendly solution. The data collection task involved compiling a parallel corpus which we would be able to use for subsequent tasks. It was a very simple corpus which had Dzongkha on the left side and English translation on the other side. All right. So how did we go about doing this particular task? We compiled the data from different dictionaries, online web scraping tools, etc. And we came up with a couple of different Excel files. In the end, what we did was we created a function, simple Python function that would append all the Excel files and give the output as a new Excel file, which had which was a compilation of all the data that we have collected. Additionally, we also added a row check functionality in our code so that we can know that whatever is going as input in our function is coming out as the main output. Then came the pre-processing task. For the pre-processing task, we needed to ensure that the characters which are not recognized by the machine translation model, for example, punctuation marks such as comma, period, inverted commas, exclamation marks, spaces, extra spaces, special characters, numerical information, all this is not unrecognizable by the machine translation model. So we needed to ensure that we remove all this before it is fed into the translation model. So we created a couple of functions that would do this for us, and we passed the data set through these functions in order to get clean data. So first of all, we started with the English text cleaning function. What we did here was, as you can see in this snippet, we removed the special characters, we removed the extra spaces, we turned it all to lowercase. We even implemented a text block functionality which would check the spell of the English words. In some cases, we observed that the text block function misinterpreted some of the words, and for example, some currency names like yen was converted to men. So that's why we tried different. We tried the machine translation model with the text block and without the text block. In the final implementation, we decided that it was best to remove the text block, so it's not present in the machine translation model. We also performed a romanization function for the Dzongkha language. We decided that if we convert it to an intermediate Roman language, then we would be able to better understand the Dzongkha input, and maybe our machine translation would be able to handle the data in a better way. However, we decided to do away with this particular function in the final machine translation model because it did not make much of a difference with or without the function. We also created a normalization and tokenization function which have been used in the translator model. Finally, we needed to understand how we were going to process the numerical information in our data. So, for example, there are integers, floating point numbers, timestamps, calendar dates, etc., which come along with the textual information. So we had to eliminate these, and we created several functions to take care of these. So what, on a high level, what these functions would do is they would replace the numerical data with a counter variable, and in the end, when before the final output was presented, they would replace the counter with the original numerical data. As you can see, this snippet at the bottom shows the output of a single sentence that we used as an example. My teammate Andrea will take over from here.
Thank you, Divya. So for word segmentation is the process of dividing text into meaningful units. And with the project that we have, Dzongkha does not use spaces to indicate the separation of the words. So a word segmentation model was the approach taken with the goal of creating a basic model as a basis for machine translation and other pre-processing tasks, such as dictionary lookup, implementing a function taking non-space input and producing spaced output. The function could be added to whatever pipeline, so in the machine translation methodology. Additionally, it was an aim to make a balance between the runtime and batch offline target. So it is to make a model that would be fast enough, but would also create highly accurate output. The model to support translators in translating digitalized repositories, known vocabulary is speed less crucial. Next slide. So as an initial approach to the word segmentation, our team tried using a unsupervised approach on entropy, which is the sentence piece, and the conditional random fields, or CRF, was also explored, as CRF is dependent on word bindings. And as a final approach for the word segmentation model, we use a basic model after Peter Norvig. So this approach uses word lists, so unigrams and bigrams with the frequency. So it combines what we call a strongest match with recursivity. And we coded it through Python with the assumption that there are no dependency and on annotated data. So we currently work with Dzongkha to English dictionary of 36,000 words. And as for the output, the frequency info and bigrams could not be retrieved. Next slide. So with this model, the overall finding is the code works fine for English given proper lexical coverage and word frequency information. As for Dzongkha, we have no frequency information or bigrams available. We tried text corpus scraping, but we are limited and we run into lack of word boundary. And suboptimal lexical coverage of the Dzongkha lexicon use. So we were working with still kind of limited knowledge on the Dzongkha language. And we also ran into oversplitting by the model. So we had encoding issues, as well as there's still room for improvement with the model. So only look up strings of syllables, which uses check. So at the right side, there's a example that it with the Dzongkha language. And the next slide would be the example of the model. So as we can see, this is in the English, and the output is the model is able to separate the English words properly, even if there are no spaces. So as you can see with the sentence, these two shall pass, it separates it properly. And next is implementing it in the Dzongkha language. So as we can see, there is the English translation as well as the Dzongkha language. And in row 210, we can see that only the word rows was segmented and translated properly. So this is the limitation we were working with in our current word segmentation model. So for the next part, machine translation by Bernardino.
Hello and thank you. So, so basically, obviously, the machine translation task in many ways could be seen as the core activity, and its overall objectives was developed to a machine translation model based on neural networks, whose input would be a Dzongkha sentence and whose output would be an English sentence. However, given the fact that we lacked a pre-trained Dzongkha tokenizer, this task had to actually work very closely with what Andrea mentioned in the previous task, i.e. the implementation of a tokenizer in order to be able to feed a tokenized sentence to the neural network. And as mentioned before, we did implement somehow a very basic version of Peter Norvig algorithm, a version that performed very well in other languages, but given the fact that we didn't have a wide enough sentence corpus, didn't work as well for Dzongkha. In the end, we had basically two outputs: a fairly simple gated recurrent unit-based model implemented in Keras, in TensorFlow with the Keras API, that reached a fairly good accuracy theoretically of around 34%, but had an actually poor performance due to overfitting, as we're going to see later. And then a script that basically implements this model and predicts the actual sentence in English for use by the deployment team. So in the next slide, I'm going to go and delve a little bit deeper into the translation model. And basically, we did try a bunch of different options. So we started actually with the most sophisticated versions. So we started with implementing an attention-based model. Then we sort of decided to revert back to simpler architectures And basically, we tried both a one-directional and a bi-directional version of an encoder-decoder architecture with both a long short-term memory and a gated returning unit. All these options were experimented both at the sentence level and also at the character level, given again that we didn't have enough data we had issues with the segmentation and tokenization. We thought that it might be worth trying at the character level, but that didn't actually pan out. Mostly we figured that it was worth settling on a simpler model at the sentence level. Also, given the fact that the average length of the sentence of the corpus wasn't that high, it was intuitively, it made sense that an attention layer wouldn't yield much better result, and that the trade-off between complexity and actual accuracy wouldn't be worth our while. So we did settle for a bidirectional gated recurrent unit encoder model. And you see the specification there on the right. So there's approximately, I think, around 30,000 parameters, trainable parameters. And yeah, and it's basically just an encoder layer and a decoder layer with a first embedding layer feeding into the encoder-decoder architecture. And in the next slide, we can see the results. The training was done, we obtained a corpus of approximately 10,000 sentence pairs, and we used most of them for the training. The problem is that, as you can see, the model starts overfitting very, very soon, even though we added 2 dropout layers with very high dropout rates, which we briefly saw before. So we started tinkering with the hyperparameters a lot in order to see if overfitting could be prevented, with very little success, even though we used, we fiddled a lot with batch size, with very, very low parameter spaces and so on. But yeah, so approximately we got around 74, 75% validation accuracy, which seems good. However, this kind of refers to single tokens, word tokens. And in the next slide, we can see that the output for a sample sentence is not as good as the actual accuracy might lead us to believe. So something like, she doesn't, sorry, she doesn't speak my language translates to she doesn't speak. So it does get, 3 out of 5 words correctly, and so that's high accuracy, but the whole sentence isn't nearly as good as it could be. We did test this model with 2 other languages just to see if the problem was with the model or with some other issues. So we tested it with Spanish and a little bit less, but also with Hindi, and it did perform significantly better in those 2 cases. So our preliminary conclusion is that the issue is not so much with the architecture of the model, but probably with the data or the segmentation. Yeah. So I think that's the last slide. Thank you. And I'm gonna leave Kaushik talk about how the implementation was carried forward.
Hey, thank you, Bernardino. Thank you, everyone. Great to be here and talk about this new use case. So what I did was, my task was to do the deployment. And in my case, I recommended doing the deployment on a cloud software. In this case, we chose the Microsoft Cloud because the other 2 were a little more expensive. And plus, I'm more comfortable with the Microsoft ecosystem. So here what we have done is we have done a more like a development setup, which is a semi-production setup. The semi-production setup consists of a virtual machine and a public IP address. And the virtual machine also needs to have some resources, because what we are doing is we are calling all the model artifacts and doing inference on the incoming text. So whatever new text we will enter, it will use the model, run the inference, and then show the output on the screen, right? That's our objective. So here we see that our virtual machine has 2 vCPUs. On the bottom right, you can see, and the RAM for this machine is 8 GB, right? So that even though training this model might take more resources, to do inference, we do not need so many resources. That is why a simple 2 CPU RAM, 2 CPU and 8 GB RAM machine is enough, right? Also, there is billing involved. So this is not free of cost. There is billing involved, and the billing is attached to the subscription ID, which is grayed out, right? And the final part of this deployment is the public IP address using which we will access the application. Okay, so you have to use the IP, and then we will have to use the port number. In our case, the port number is 8051. Can you go to the next slide, please? Okay, so the Docker file, we are using the concept of Dockers, and in a Docker file we will create the environment, we will expose the port, we will upload the source code, and then we will install all the required libraries. Finally, we will just set the program to run at its own pace, right? So we are seeing that our beginning image is a Python Slim Docker. A Slim Docker is good for production because it does not have all the heavy libraries. It only has the very basic libraries needed to run the program. We are using the work directory as app. This is almost standard in every case. We are installing some common software that are required for Ubuntu and Linux to work. We are copying all the source code files into the work directory, which is /app. And finally, we are installing all the requirements. These requirements has Keras, Pandas, Scikit, and TensorFlow. So these 4 libraries it has. And finally, the command to set it to run in server mode is streamlit run, the source code file, the custom port, and the server address. So once we create this and we give it a bunch of commands, it's going to compile this file, create a immutable artifact, and then use this image as a runner or as a backend for the model service. So if you go to the next slide, there should be, yes. So if you see that this file, this is actually a text file. The previous Docker file is actually a text file. And to use it, first we will need to build that file into a compiled image. The command to build that file is docker build -t. So -t gives you the image name, and the dot tells you that the Docker file is in the same directory, right? The Docker run is a -restart always, which means anytime the application or deployment goes down, it is automatically going to restart and keep the application running. This is very important for the deployment part. Otherwise, if your services go down, all your other downstream applications might be affected. And finally, the port number we are exposing is 8051. This port, we have it open in the virtual machine so that we can access the application and run our software, right? And finally, if you are using this application on the front end, you can also go to the back end and check out what is happening, all the input that the people are giving, what kind of time it is taking, and all the standard outputs. To do that, you will have to type in Docker logs, the container name. So this container name is just custom. You can use any name as the container name, right? If you go to the next slide. Now, this is something that I've shown. Like I said, I did a development setup, a semi-production, an actual production setup. If you want to do this at scale, like for 10,000 people, if you want to do this, then you have to use something called an Azure App Service. The app service is actually accessible from mobile apps. It is accessible from normal web consoles, from third-party APIs, and also from server processes using functions. So if you want to use this in the production process as part of a bigger pipeline, then this is what you should do, right? Also, again, you can use Streamlit to create a basic UI. Yeah, that's it. And this is the actual demo. If you notice that the IP is there, and beside that we have the port number. See, if you input the Dzongkha text and click on translate, it will run all the code and the model at the backend and give you the output as English output. This is the whole point of the deployment, to be able to see it as a hosted web application on the internet, available for the public. That's it. Thank you.
Yeah. Over to Divya. Thanks, Kaushik.
Thanks, Kaushik. So these are some of the issues and challenges that we faced for this particular project. First and foremost, we did not have enough data, and we never had annotated data which would help with the word segmentation task. So due to unfamiliarity with the language on part of the team members, this posed a major complexity in our project. Additionally, we also had some problems dealing with the numerical information. So replacement of the numbers, the integers, floats, or timestamps with the counter variable. It took quite a significant amount of time in order to figure it out. Next slide. The future scope, this is what we outlined, that we can improve upon our existing model by working on these few points that were observed by the team. First and foremost, we can test for different combinations of the test train data. We can also try using some additional training data in order to create more accurate results. A bigger size of data set would definitely help improve the model accuracy. Plus, it would add a little bit of diversity to the data. We felt that the data set we were using was quite repetitive, which led to overfitting of the model pretty soon as we started the machine translation task. We can also explore the possibility of skipping word segmentation task for the machine translation model. Some of the key takeaways that we identified include maybe the poor performance as highlighted by Bernardino earlier in the machine translation task. Maybe the possibility is there that due to lack of tokenization or due to some lack of segmentation tool, a clearly identifiable segmentation tool, the model tends to overfit for our data set. When he ran the model with some other languages such as Spanish and Hindi, it performed significantly better than our use case. And as highlighted earlier, the amount of training data that we collected was quite less to have a high accuracy machine translation model. And the possibility was there that the data set we were using was imbalanced in a way. So we can try rebalancing the training data set by adding more data. Next slide. That's it from my side.
That's it.
I'll be handing it over to Akash. Thank you.
Yeah. Thanks, Divya. So team, so that's it from our side. Thank you for giving us opportunity. Yeah, over to you, Harmi.
Thank you, Akash, and thank you to everyone who presented here, along with the collaborators who were responsible for the presentation. I'd also like to thank the Bhutan team, and if they have a few words to say, they can share it, and then we can go for the end of the presentation.
So I guess we have some questions regarding the way forward.
Questions up to the questions.
Okay.
Just a few words.
So I guess from oopsie.
Hello.
Hi, Bhima. Yeah.
Okay. Hello. So just wanted to say that here from Druk Holding Investments perspective, we can see the sheer amount of work and effort, as well as kind of the complexity of, we know the complexity of the Dzongkha language and everything. So hearing Akash and team talk about all of the intricacies and everything, we can see the amount of time and effort that's gone into looking at the issues. I think this is a I think I, as well as the team, we really think this is a really good start into tackling this very, very important need that we have here in Bhutan. And as a country which is really looking at applications for very novel, I wouldn't say, I guess relatively novel for Bhutan, applications of these technologies like AI and ML and everything, this is a really useful step. And as we get more and more success in this work that Akash has given us, we're going to be able to really show Bhutan, our people, as well as society, and what do you call it, the whole nation, how powerful and how useful this type of technology is. So I guess from our side, we really want to say thank you so much to Akash and team. And also thank you so much to Omdena for providing this platform and connecting, the network and everything. For us also, this was our first experience dealing with something with an organization of the scale of Omdena, with the depth of resources with Omdena and everything. And for us, the bespoke help that we received, as well as all of the guidance and camaraderie we had, we're very grateful for that. So just want to say thank you to Omdena as well. So that's basically the few words we have to say towards you guys. So thank you so much, Akash and team, and thank you, Omdena.
Thank you, Pema. Your
Thank you.
support as well was very crucial for us to carry on things. And we hope to have the collaboration in the future as well.
Definitely.
Thank you very much for joining the session. And let's have a good evening or good morning at the different time zones. Bye.
Bye-bye.